So I'm sure you all are wondering, how in the world does the Zanderbuilt concentric selector system work? So what I've done is I've laid all the components out and I'm going to put them together in a way that you wouldn't normally assemble it so that you can understand what the different components do and where they go. Starting off at the center of the transmission, we have a long center support tube that receives oil through this hole in the bottom of the case that goes up through here and then feeds the center support tube. That oil is then transferred through the transfer shaft. So this transfer shaft is what connects these carriers together. I'm going to go ahead and assemble these so you can see the parts that make these. So we have two of the same carrier half. Have a central carrier flange that splines into the transfer shaft. So these slide onto here. And then we have carrier. These bolt together with 4 of these 5/8 bolts. But for now, I'm just going to slide this in here. That's the input set looks like. Then for the output set, same thing basically. This is the same. This is the same. This is slightly different. Clips together, again, 4 5/8 bolts, and then this just slides in, splines onto the transfer shaft. So this is very well supported, but this transfer tube is not the only support that this shared common carrier receives. It also receives support from the selector sun gear shafts that have bushings that ride on the outside of them, as well as the I believe this one. So you'll notice there is a bushing face here and in this carrier, and then all of this is one giant bushing together that nicely sits on that center support tube. So this center support tube helps packaging efficiency a lot, makes it really compact, and it really helps to support this carrier well. The output set is, again, basically identical, except this half only contains one selector sun gear there, which is this one. Put that together, and this gets maybe this one. Yes. So this just simply splines into the same transfer shaft. Do it again. Like that. So you can see this is really well supported. It's supported inside of the transfer shaft and on the outside of the transfer shaft tube. So it's a single carrier architecture. This is always locked together 1-to-1, and you can see it's really stable. And it's getting a lot of oil from that dedicated oil port. That lubricates all the selector sun gear shafts, all the gears, that transfer shaft, as well as the other shafts that sit in here. This is your input shaft, this is your output shaft, and then these are 2 more selector sun gears. So I'm going to go ahead and put these in with the remaining drums and show you everything else from there. So I've gone ahead and installed the clutch drums, and I put colored tape on, which corresponds to the colors on the screen. So as you will notice, carrier spins as 1 as before. The red clutch drum connects only to that selector sun gear, purple to that selector sun gear, the yellow to that selector sun gear, and the white to that selector sun gear, and the input shaft to itself. Same on the output side. We have the orange selector sun gear, the green selector sun gear, the blue, and then finally the output shaft. So nothing happens until we install the planet gear shafts into the transmission. As I'll show in the next clip, these make the carrier rotate and then make the output shaft rotate, which I'll explain next. So I've gone ahead and installed an input planet gear shaft and an output planet gear shaft. There's typically 4 of these, but I've left those removed so that you can clearly see what's going on inside. So the input side has 4 clutches, the output side has 3, 4 times 3 giving us 12 gears. So what we're doing with the input set, as you can see inside here, is we have our input shaft, which is driving our planing shaft. And until we turn on a clutch, nothing happens. So I'm going to turn on the 1A clutch, which is this red one. We've just locked this sun gear to the case. So this is unable to rotate. And we're going to, as we rotate the input shaft, it's going to turn this planing gear shaft. But this planing gear shaft is contained inside of this common carrier, and it is forced to rotate around this locked selector sun gear. So as I rotate the input shaft clockwise, you'll notice that the carrier is turning anti-clockwise. There are 4 distinct ratios in the input set. So as I cycle through these clutches, it will change the speed and torque of this carrier. So then moving on to the output set, we have essentially the input set flipped. So instead of inputting on the sun gear, outputting on the carrier, we're now inputting on the carrier, outputting on the output sun gear shaft, which is this one right here. So what happens when I turn on an output side clutch, like this orange one, is as I rotate the carrier anti-clockwise, notice the direction rotation of the output shaft. See how it's going in the opposite direction of the carrier, and therefore the same direction as the input shaft. What we're doing here is the carrier is being driven by the input set, but since it's the same carrier and it's always connected 1-to-1, the carrier is forcing this planing gear shaft to rotate around this locked selector sun gear right here. This is the one splined to this orange clutch. So as the carrier is rotating the planing gear shaft around that, it is forcing the output shaft to rotate. So that's how the forward gears work. There's 3 distinct ratios in the output set. So 4 times 3 giving us 12 speeds. So how do we get reverse? We get reverse for free because, as I've already mentioned, the carrier is already rotating in reverse at an underdrive ratio. For shallow reverse ratios, we can use this sliding clutch right here. I'm gonna go ahead and turn it on with software. Reverse engaged, forward, reverse, forward, reverse, forward. So what we're doing here is there's 2 methods. There's the simple method. What we're doing with this is we're simply locking the output set to itself. So if this is forward operation, you can see that the gears are functioning normally. When I engage this clutch, you'll see that they're locked up to the carrier. So the output shaft, or the final output, is now locked to the carrier. So as I turn on a single input side clutch, like 1A, as I rotate the input shaft clockwise, the carrier and therefore the output shaft is rotating anti-clockwise. This works great for shallow reverse gears, but for automotive wide range and commercial wide, a deeper reverse is required. So we'll move to this more complex slider clutch. What we're doing is we're uncoupling the final drive from the output shaft, and instead we're coupling to this 2B selector sun gear shaft, and we will be using this as our output shaft. We will be turning on the 1B clutch as well as one of the 4 input clutches. So watch what happens when I leave this in forward and turn on first gear. So as first gear is on, you're going to notice it's rotating in normal forward direction. But when I slide this clutch into the reverse position, notice that the direction has now changed. I'm going to move this back to forward. See again, we're in forward rotation. Moved in reverse. We're now in reverse. So we get 4 different reverse gears simply by changing which A clutch is turned on. The reason this happens is you'll notice that the output gear is physically smaller than all of the output selector sun gears. The input gear is physically smaller than all of the input side selector sun gears. So what happens when this gear is smaller than the locked selector sun gear is that the output will spin in the opposite direction of the carrier. When we use our fancy reverse setup with the sliding clutch that disconnects the final drive from the output shaft, and we connect the final drive instead to the 2B clutch, which is this one right here, we will turn on the 1B clutch, which is this, and you'll notice the output is now larger than the locked selector sun gear. That causes the new output that we're using in reverse to rotate in the same direction as the carrier. And since the carrier is going at a reduction in the opposite direction of the input, we get an even deeper reverse gear. And that is how we achieve a variety of reverse ratios without any additional gear sets, simply by changing which sliding clutch we use and which shafts are connected in reverse. So hopefully that helps you understand exactly what's going on in here. It's really quite simple. The only complex part is calculating the physical size of the gear teeth required and getting everything to package correctly, keeping the RPMs low, and just getting the best possible balanced and stable combination of these parts. I'd like to show the type of clutches I'm using in the Concentric Selector system. Currently I'm using 7 identical brake band clutches. So these are very good at holding a lot of torque. There's one used in the legendary Turbo 400. They are launched at over 3,000 horsepower. You'll notice that my clutch has a significantly larger outer diameter. The width is slightly narrower. So a huge advantage to these is there's no rotating fluid seals. All you're doing is applying pressure to a piston, moving a push rod that presses on the band and squeezes it around a drum. So these type of clutches are self-energizing, meaning that at a certain point, the more torque you apply to this, the more this band will hold, because as you squeeze this together, this drum is sucking this together. So when you orient these in the case, you need to be mindful of the direction at which you're applying pressure to it. Luckily, all the input side is the same, all the output side is the same, so they're oriented correctly. So what I'm doing here is I'm locking these selector sun gears to the case. So I'm going to go ahead and turn the purple clutch on right here. Purple. So now you'll see that this one is locked to the case. The red one is free to rotate. The only clutch on is this purple one. I'm just locking it to the case. When I change to the red clutch, which is this one, you'll see that I can now rotate the purple clutch. The red one's locked to the case. So neutral, none of the clutches are on. They're all free to rotate. So I'm doing the same for these clutches and these clutches. They're all the same. They're basically, they're all the same drum, basically, except for the spline interface. Some of them have a bushing face on them. And all the bands are identical at this point. They're a very heavy duty band. I have a chart here showing the Turbo 400 and Powerglide band versus the Zanderbuilt band. There's a lot of information in there. I'll post that separately. So I have a lot of other videos. Be sure to check them out. Thanks for watching.